Number 4 is taken from the International Edexcel Maths A-Levels Pure 2 Sample Assessment Material 2018. Given n belongs to the natural number set n, prove by exhaustion that n squared plus 2 is not divisible by 4. Way 1 is that you place a value, or you assume a value for n, and you start replacing n in the expression and finding the answer and checking that the answer is divisible by 4. Mainly, this is what they mean by exhaustion. So let us start with the odd numbers. N equals 1. If you replace it here, you're going to get the answer for 3, and 3 is not divisible by 4. N equals 3, you replace it in the expression, so it's 9 plus 2 equals 11, where 11 is not divisible by 4. Also, n equals 5, it's 25 plus 2, which is equal to 27, which is not divisible by 4. So for taking or exhausting the odd numbers, you find that, or you notice that the answers out of these numbers, they are not divisible by 4. Let us choose the even numbers. N is equal to 2, so 2 squared is 4 plus 2, which is equal to 6. 6 is not divisible by 4. If n is 4, the answer is going to be 18, and if n is 6, the answer is going to be 38, where both are not divisible by 4. So we have used exhaustion in order for us to prove that the answer for this expression is not divisible by 4. Keeping in mind that n is a number where it's taken, n is a set of numbers, of natural numbers, where n is equal to 0, 1, 2, 3, 4, 5, etc. Now you're going to say, why didn't we take 0? Even if we take 0 and we consider it as an even number, this is going to be equal to 0 plus 2 equals 2, where 2 is not divisible by 4. Now this is way 1. If we want to use the general form or general explanation, and we want to prove that this question is true, then we start by taking or considering n is an even number, where if you're going to write an expression for an even number in a general form, it's going to be 2k, where k is a constant. You can write it as 2t or 2c, it doesn't matter, as long as you have the factor or the coefficient 2, because anything multiplied by 2 makes it an even number. Therefore, the question is asking us n squared plus 4, if you find its value, is it divisible by 4? So this is why you find here that it's n squared plus 2 over 4. So we are actually taking the general term and we're dividing it by 4, because this is what the question wants. So therefore, you replace n by its general form, which is 2k, you square it, and then you split the fraction. Splitting the fraction will give you 4k squared over 4 equals to k squared, and the second splitting, you will have 2 over 4 equals to 1 over 2. So if you look at the answer, it has a fraction, and the fraction means it's a decimal and it cannot be a whole number. Therefore, the division of this expression by 4 is not going to give you a whole number. Therefore, it's not, if n was an even number, you are going to get a value when you replace it in the expression that will not be divisible by 4. Now, suppose that n is odd, the general form of writing an odd number is 2k plus 1. Therefore, you replace the value of n in n squared plus 4 divided by 4, because this is what the question wants, and you replace it and then expand. Expanding will give you 4k squared plus 4k plus 1, because we are using the identity a plus b squared, which is equal to a squared plus 2ab plus b squared. Now, after the expansion, you collect, and this is going to be your final answer, which is 4k squared plus 4k plus 3 over 4. Now, taking this into consideration, which is splitting the fractions, so we're going to split 4k squared over 4 and check if we will have a whole number when we're dividing all of this expression by 4. So if it's divisible by 4, then we can say that the expression can be divisible by 4. Therefore, 4 divided by 4 is k squared, and 4 by 4 is k, and 3 over 4 is a decimal number. Therefore, you are going to have a remainder when you're dividing this expression when n is odd by 4. So in conclusion, when you are asked to in this question we are asked to prove that this expression n squared plus 2 is not divisible by 4, and I've used two methods. One method of assuming a number and proving that the value in the end is not divisible by 4, and then using in way 2 another method, which is taking the general form and proving that the value in the end is not divisible by 4.